Consider the graph of the cubic function f of x equals x cubed plus 3x squared minus 24x minus 20. We can see from the graph that it increases from negative infinity to negative 4, decreases from negative 4 to 2, and then increases again from 2 to infinity. Recall that the derivative f prime of x can be interpreted as the slope of the tangent line to the graph. We can see that any tangent line in the first interval from negative infinity to negative 4 has a positive slope. In other words, f prime of x, the derivative, is positive for any x value in this interval. At x equals negative 4, the tangent line is horizontal, which means the slope is 0. Then from negative 4 to 2, all the tangent lines have a negative slope. At 2, the tangent line is again horizontal. And finally, from 2 to infinity, all the tangent lines have a positive slope. Without the graph, given some function, we can use the derivative to find where the graph is increasing and decreasing and attains its maximum and minimum values. The derivative of this function is f prime of x equals 3x squared plus 6x minus 24, which we factor to get 3 times x plus 4 times x minus 2. The derivative is 0 when x equals negative 4 and x equals 2. Then we create a sign chart with the intervals around these x values that we found. If we plug any number from negative infinity to negative 4 into the derivative, we get a positive answer, which means the function is increasing on this interval. Then from negative 4 to 2, we plug in any number from there, the derivative is negative, which means the function is decreasing. And on the last interval, choosing any number from there and plugging it into the first derivative gives a positive answer, which means the function is increasing. Since the function goes from increasing to decreasing on these adjacent intervals, x equals negative 4 is called a relative max. Then on the next adjacent pair, at x equals 2, the graph is going from decreasing to increasing, which means x equals 2 is a relative minimum. The important points on this graph are x equals negative 4 and x equals 2, since these are the values where the graph changes from increasing to decreasing. They are the x values where the derivative equals 0. We call such points critical points. In general, a number x equals c is a critical point of a continuous function f if c is in the domain of f and either f prime of c is 0, as in our case, or f prime of c does not exist. Since our function is a polynomial, there are no values such that f prime of c does not exist. So for our function, any critical points come from setting the derivative equal to 0 and solving for x. Then this sign chart that we construct around these values allows us to classify the critical points as relative minima, relative maxima, or neither. This process is called the first derivative test. The critical point x equals negative 4 is a relative max since on the left of negative 4 the function is increasing and on the right it is decreasing. For x equals 2 the function is decreasing on the left and increasing on the right. So by the first derivative test x equals 2 is a relative min. There are lots of examples of functions for which a critical point is neither a relative minimum nor a relative maximum. For example, f of x equals x cubed. The derivative 3x squared equals 0 when x equals 0. At x equals 0, the tangent line to the curve is flat, but since the graph increases on the left, then continues to increase on the right, x equals 0 is neither a relative min or a relative max.